Welcome students to lesson 2 of the natural hazards topic. Last lesson we explored the idea of a natural hazard and hazard risk, and I showed you that there are different types of natural hazards. In this lesson we're going to dive deeper into tectonics of the Earth, which you will have learned about in years 7 and 8. We're going to explore what happens at plate boundaries on Earth's crust and why this is so important in the formation of earthquakes and volcanoes. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10, answer the questions from memory and then mark your answers. Game time. Earthquakes and volcanoes are mostly found along plate boundaries. Distribution means how something is spread out over an area. For example, volcanoes around the world. 3. Oceanic crust is found under oceans. 4. Continental crust is found under the land. 5. Most earthquakes in South America are found along its west coast. 6. Hazard risk means the chance people will be affected by a natural hazard. 7. Oceanic crust is denser than continental crust. 8. Volcanoes occur when hot liquid rock called magma rises through cracks in the Earth's crust. 9. Earthquakes occur when friction causes tectonic plates to get stuck at plate boundaries. 10. Convection currents of rising hot rock in the Earth's mantle spread out under tectonic plates, dragging them apart. Give yourselves a mark out of 10. If you got 8 or more, fantastic work. Any questions that you got wrong, test yourselves on them repeatedly until you know them by heart. To introduce this idea of plate boundaries, again, at the GCSE level, I'm going to show you a photo and some questions. Answer the questions using your understanding. Here's the photo. So number 1, what is happening in this photo? Well, you should have said that in this photo, 2 continents, the North American continent and the Eurasian, are spreading apart. You should have said there's a gap for number 2 because as these plates spread apart, the crust is pulling apart as well, the Earth's crust. And consequently, there's less rock remaining in between the 2 plates. 3. What natural hazard might be found in this kind of place? Well, you could have said earthquakes or volcanoes, and we're going to explore both of them and why they happen at different plate boundaries in this lesson. Keywords for today. These 2 materials, carbon fibre and laminated wood, they're both made of layers of materials added on top of each other. Similar to a cake, they're stuck together on top of each other. They're not made of just one piece of material. There's a word for that, and it means a composite. Similarly, a volcano is made of layers of material, lava and ash, that are deposited, laid down after every eruption. And so volcanoes are also composites. That's why this type of volcano is called a composite volcano. And the other word today is this. This is a liquid, maple syrup, that isn't as watery as some liquids. It's said to be viscous, which means it's sticky and it flows slowly, for example Marmite or honey. This is similar to lava that flows out of a volcano. So the big question we need to answer before we understand what happens at plate boundaries is, why do tectonic plates move? Imagine a pot of water on your hob or your cooker. What's actually happening when you boil that water? Well, when you heat up the water from the bottom, it's the water lowest down that gets hottest. And as that water gets hotter, the molecules of water spread apart. And so, in the same amount of area, there are fewer molecules of water. And so it becomes less dense. Think of how a sponge has lots of holes of air within it. There's very little actual material there, it's mostly air. and so a sponge floats on water. Less dense objects, such as sponges, float on top of more dense objects or liquids. Hotter substances are less dense than colder substances of the same type because their atoms or their molecules are spread further apart. And so this hot water that's really hot down at the bottom of the pan, it rises up because less dense objects rise up. They float. Now when it's risen further away from the heating source at the bottom of the pot of the pan, it cools down. Due to evaporation, it cools down. And when it cools down, the molecules come closer together, and so it becomes more dense. And so the cooler water sinks. And this process repeats and repeats in a circle. This is called a convection current. Convection is the process where hotter substances rise, cool down, sink back down again as colder substances. They heat up again, and so you get this circle. Inside the Earth, a similar process happens. The Earth's core is the hottest part of the Earth. It has been extremely hot for the last 4 or so billion years. And because it's the hottest part of the Earth, it, similar to a heater or a cooker under a pan of water, heats the rock at the bottom the most. And so this layer, the widest layer of the Earth, the mantle outside of the core, is heated up by the core. And the rock closest to the core is heated up the most, liquefies, becomes the hottest and the least dense, and so it rises towards the crust. As it rises, it spreads out when it meets the solid crust. And as that liquid rock spreads out, it drags the tectonic plates of the Earth along with it, causing them to spread apart at some points here, and causing them to collide at other points here and here. As the hot rock spreads out, it cools down because now it's further away from the core. And it slowly begins to descend back to the core because it's more dense. And this process repeats and repeats and repeats constantly, meaning that tectonic plates constantly move. And that's why, in millions of years from now, the shape and position of the Earth's continents will not look the same, because the tectonic plates are constantly moving. Some parts of the plates are moving apart, and in some places they're moving towards each other. So let's summarize. The core heats the mantle of the Earth. This causes the rock in the mantle to melt, and that melted, hotter rock becomes less dense, and so it rises. As it rises, it spreads out beneath the crust. Due to friction, similar to the friction that you get when you slide your hand across a table, the rock spreads out the crust. As the rock cools down, it becomes denser and so sinks back towards the core, and the process repeats. This is why tectonic plates move. Not all plate boundaries where plates meet are the same, because in some places, as you see here, they're moving apart. In some places, as you see here, plates are moving towards each other. And in other places, they're sliding past each other. I'm going to show you now what processes happen at each plate boundary where plates meet. So the first type of plate boundary is called the constructive boundary. And here you get flat volcanoes like this that erupt with liquid magma like this. This is called a constructive boundary or a constructive margin. And at constructive boundaries, tectonic plates, usually oceanic crust, spread apart. The convection current from the mantle spreads the tectonic plates apart as it spreads out beneath the crust. As the crust spreads apart, this creates a gap, or a fissure, F-I-S-S-U-R-E, between the two tectonic plates. This allows the hot magma within the mantle to rise through the crust and erupt as a volcano. However, because the magma is so hot, it remains liquid, and so it's non-viscous, it flows really easily. And because it flows out of the volcanoes very easily at these plate boundaries, it spreads out very far, and so you get these flat, low volcanoes called shield volcanoes. They're shaped like old shields. They're also not very explosive, these volcanoes. As the magma, which is now lava as it's reached the surface, spreads out, it cools down and hardens to form new crust, either beneath the sea or on land. And so at constructive boundaries, you get volcanoes, but you also get earthquakes. As the magma rises through the cracks in the crust, it presses against the rock that it blasts through, creating vibrations, earthquakes. Not only that, it doesn't push the tectonic plates. So to review, in the upper mantle, you have semi-molten rock, so not quite liquid, but it's able to move. Convection currents within the upper mantle spread out beneath the crust at constructive plate boundaries, causing the tectonic plates to spread apart. Often this is oceanic crust beneath the sea, and this forms volcanoes and earthquakes. Earthquakes also form here because the plates do not spread apart at the same speed all along the plate. Some parts are pushed apart faster and further than other parts because more magma is coming out, or the convection currents are stronger there. Consequently, the rock cracks as some parts of it want to pull away faster than others. That sudden cracking of the plate causes earthquakes. What about destructive boundaries? At a destructive boundary, you get massive explosive volcanoes like this, Mount Pinatubo in the Philippines. So what's actually going on? Well, at a destructive plate boundary, plates are colliding. Oceanic crust is subducting, which means going beneath continental crust. And this happens because the oceanic crust, while thinner and younger, is also denser than continental crust. It's made of dense basalt, whereas continental crust is made of less dense granite. As you know, denser objects sink below less dense objects. It sinks into the hot upper mantle, up to about 4,000 degrees Celsius, but averaging around 2,000 degrees Celsius. As the oceanic crust slides past and beneath the continental crust, when it subducts, it causes friction with the continental crust. And this friction, combined with the oceanic crust going into the hot mantle, causes it to melt. And that melting creates a vast pool of magma beneath the plate boundary called a magma chamber. The collision between these two pieces of crust, these two tectonic plates, causes the continental crust to fold upwards, creating fold mountains like these. It also creates large fissures, cracks within the continental crust. The oceanic crust contains water above it. Additionally, dead creatures, such as old shellfishes and crustaceans, which are types of fish which have shells, are deposited and build up on the surface of the oceanic crust. These creatures contain carbon, and carbon dioxide is also within the water. Now, if you've ever had a fizzy drink and shaken it up and then opened the bottle, you'll know it comes firing out really fast. The carbon dioxide wants to be released. As that carbon dioxide is dissolved in the water, and the carbon locked in the bodies of these dead animals descends with the oceanic crust into the mantle, that carbon dioxide is released, and pressure builds up as it tries to escape. And so it fires through the fissures and the gaps in the continental crust as a super explosive volcano. This becomes a composite volcano over time, as the very viscous, thick and slow-flowing magma and ash build up to form steep-sided volcanoes such as this one, Pinatubo in Philippines. At destructive plate boundaries, therefore, you get great earthquakes as the friction between the oceanic crust and the continental crust causes the plates to jam. However, due to the movement of convection currents, the oceanic crust continues to want to descend beneath the continental crust, and so the friction builds up, and then suddenly the plates release, creating earthquakes. The closer the earthquake happens to the surface, so here, the more powerful the earthquake is. The deeper the earthquake happens, the less powerful the earthquake is, because the seismic waves have to spread through more rock, and so they weaken before they reach people on the surface. What about conservative plate boundaries? At these plate boundaries, plates aren't moving away or towards each other, they are in fact sliding past each other like this. This is the San Andreas Fault in California, in the west coast of the United States of America, and it shows the plates crumpling as they slide past each other. In this case, oceanic crust, the Pacific plate, is sliding past continental crust, the North American plate. As they do so, friction, due to the plates jamming, builds up. And this causes enormous amounts of pressure to build up between the plates as they want to continue to slide past each other. Eventually, in one sudden jolt, the plates release and move, and that creates huge earthquakes that have very shallow foci. A foci is the plural of the focus. The exact point of the earthquake is very near the surface, and consequently, at conservative plate boundaries, you often get very powerful earthquakes that damage buildings and kill people. You do not, however, get volcanoes at conservative plate boundaries because there is no gap or fissure in the crust for magma to rise through. Time to assess learning. Please write 1 to 8. Answer the questions from memory and then mark your answers. Number 1, destructive. Number 2, conservative. 3, shield volcanoes, constructive. 4, destructive. 5, convection currents. 6, it melts. 7, a gap or crack or fissure in the crust. And 8, friction. Give yourselves a mark out of 8. If you got 6 or more, you really understood this. Time to embed the learning. I'm going to show you a couple of questions using a picture. Answer the questions using the understanding you've gained this lesson, and then mark your answers. So number 1, what happens to oceanic crust at a destructive plate boundary? You need both of these points. Number 2, describe how earthquakes and volcanoes happen here. Make sure you use all these keywords and complete these parts. So you should have had an answer like this. These are the 4 key parts you need, underlined keywords. Give yourselves a mark out of 6. Add any corrections in green pen or any missing parts. If you got 5 or more, you really mastered this lesson. Well done. If you haven't got 5 or more, watch the explanation again in a week's time, then attempt the questions again as well. From this lesson, write 2 questions. Answer them from memory, and then in a week's time, test yourself on these questions to see if you remember the ideas. Next lesson, we're going to dive deeper into the distribution of earthquakes and volcanoes around the world, so where they are found and why. And we're going to build on the learning about what happens at plate boundaries from today. Join me then.